So this is going to be considered a level 2 empirical formula problem, not because it's especially hard, but it's because there's a second step, and the second step might feel a little weird at first, but once you've done it a few times, you'll be like, oh, that's really easy. All right, so same setup as before, and remember that I'm assuming 100 grams. I would not have ever actually used 100 grams because that's a lot to waste. But we're going to assume that because remember the ratio, if it's a pure sample, remember the ratio of the elements is going to be the same regardless if it's a little sample or a big sample. So the ratio should all be the same. And we're using that number because it makes it really easy to move those numbers into grams. So that's in the last video. But I'm going ahead and just writing them down as grams. Now, you can also do these problems like I also said before. If you were just given a gram amount, so like if that just said grams, just go straight from there. Don't like try to convert it into, percentage and then convert it back out. Don't do that. Just take it from grams. It'll work that way also. So this all will depend on the instrumentation you're using, like how they will give you just the information that you need. So sometimes they may, if you're lucky, go ahead and calculate what I'm calculating right now. But in all honesty, they may not. These things are very expensive. So grams of H and 1.01 in 1 mole of H. Again, if you weren't sure about that, there's my carbon. That's the 12.01. And then over here, I'm going to take it to the H. There's my H, 1.01. Because I'm rounding them to the hundredths place. I'm going to pull my calculator over here, and it'll do 82.6 divided by 12.01, and that gives me 6.877. Remember to use some extra sig figs with these. I'm taking it 5. I know I could have just taken it 4. I'm just having to be taking it 5. 17.4 divided by 1.01. It's going to be really close to the 17 number, 17.227. Now you already remembered the next step, right? Because you did it when you were doing the regular empirical formula. I like to change colors just to emphasize it. Remember, you're going to divide by the smallest. So that's not new. This one is smaller. It's not always the top one that's the smallest. It just was coincidental that I wrote that one in there. 8776. And I don't even have to put this in the calculator. I know that comes out to be 1 mole of carbon. This one is already in the calculator, so I'm just using that number and just doing divided by 6.8776. And that gives me 2.5, and I can do the 0.4 if you want me to, moles of H. So the problem with this is that, yeah, it comes out to be C, and there's an understood 1 there, H 2.5. And again, we cannot use something that has a decimal in it because it implies that there's half a hydrogen atom, and you can't have half a hydrogen atom. So we need those to be whole number ratios. It just is hard to see the ratio also if they're not whole number ratios. So here's what you do. You just start multiplying by numbers. This sounds so funny, but seriously, you can just start multiplying. So if you multiply both of these by 1, you're not going to get anywhere. But you can try multiplying by 2 and by 3 and by 4. And what you're looking for is where you get some number that's like, 4.99. That kind of a number is okay to round up to 5. But in these problems, because our instrumentation is so very particular, if you have 4.8, you cannot round that one up. So rounding in this one is weird with this, and this is like the only time I can think of this semester where this is the case. You don't want to round unless it's really, really close to the number. And again, it's because of the instruments that we have. Now, when we have students doing these in labs, these kinds of problems, our instrumentation we use in our general chemistry labs, it's not good enough to say, oh, well, you have to be this specific. But the numbers that we're giving for the math problems, you do have to be that specific. I know it seems like a real pain. So we're going to just try multiplying by numbers. And I like to start at 1, 2, 3, 4. And so and again, 1 won't help us. You can see that 1 won't help us. But let me try 2. And I usually do it with the one that has the decimal first to see if it fixes the decimal. So times 2. Like it gives me 5. Do you see how sure that 5 is? That's great. I'm going to multiply that one times 2, and that gives me my formula. It's C2H5. Now, if I had skipped the 2, let's say I had skipped the 2 and I had jumped to 3, that number, that 2.504 number, 2.504, if I had multiplied that by 3, do you see how that's not an even number? So it can't be the times 3 one. I can even try the times 4. You'll see that one won't work either. 2.5 times 4. Well, okay, sorry. It did work. Let me show you what happens when you get, if you multiply both of them times 4. You end up getting this times 4, 10, and then this one times 4, and that gives me 4. You end up with C4H10. Now, what's the problem with that one? It's not an empirical formula. It simplifies to this one. So it's good to know that you can end up, with larger numbers that will simplify, but this is not the right answer. You're always going to be asked about that empirical formula. You need to get it to the empirical formula. If later you're given information to help you then, a multi-step problem, get to this problem, this number, then that's fine. But you have to solve these so that you're getting the empirical formula. Last little note, there are endings. Some places will have you just look for numbers that end with 1.5. If you have a 0.5, they're like, oh, just go ahead and jump to the times 2. A 0.33 or a 0.66, a 0.5 also works, or there's another one. But they'll give you these numbers and memorize them. I just think it's actually probably faster. You don't have to look this up in your notes, this information. I just think it's faster. Just start with a low number 2, multiply whichever one is causing you fits, times the 2 or times 3 or times the, or just start with 2 and work your way up. You might have to go up to 5 even, or 6, But just work your way up. 6 is going to be like 3 though. And I just think that's easier and faster. But if you like to memorize, you can do that. There's a video in the playlist that will show you this exact thing where you have a list of numbers. And that's all the extra step on the level 2 empirical formulas.